Hi class, in this recording we're going to focus on lymphocytes. To review, there's three broad categories of cells or major kinds of cells within our immune system. The adaptive immune system, specifically with the lymphocytes, the macrophages, and the dendritic cells. We find that we have lots of these in skins, or tissue types I should say, that are exposed to lots of attack. So lymphatic organs, our skin and mucous membranes are going to have higher concentrations of pathogens. So to combat that, we have higher concentrations of white blood cells in those areas. Within the lymphocytes, there are three categories. We have natural killer cells, which we've already talked about in detail, but we also have T lymphocytes and B lymphocytes. So let's dive into it. As we look at T lymphatic cells, or T cells, or T lymphocytes, they are going to maturate in the thymus. And I want you to think T cell thymus. So they come from the red bone marrow, go to the thymus to be educated or become immunocompetent. So when we say educated, we're referring to becoming immunocompetent. And then once they're educated or develop immunocompetency in the thymus, they are then going to travel to other tissue types of the body. So we'll start off with our red bone marrow, making both the cells of the T lymphocytes and the B lymphocytes, all coming from that red bone marrow. And the reason I'm talking about red bone marrow and I'm showing the sternum right here is that the sternum is a flat bone, and this flat bone of our body has a lot of red bone marrow within it. Now, when those T lymphocytes are in the thymus, those T lymphocytes are going to be exposed to chemicals that promote the maturation process. Those chemicals are released by cortical epithelial cells within the thymus, so within the cortex of the thymus. And then on the T lymphocytes, they are going to have receptors added. So they develop the surface antigen receptors, and now that they have surface antigen receptors, they are immunocompetent. They can recognize antigens that are presented to them, and we have a positive selection process, which means we are going to select for ones that don't recognize self-proteins. If they are immunocompetent and they are going to recognize bad antigens and not recognize good antigens. The moment they start recognizing good antigens or self-antigens, we have a problem. We have an immune-based disease, or one of the diseases where our own body starts to attack itself. So as we look at these T cells that are maturing in the thymus, the medullary epithelial cells of the thymus are going to test them. So they become immunocompetent, and now we're going to go through that positive selection testing, where the medullary epithelial cells within the thymus are going to expose our little aspiring T cells to self-antigens. And if the T cells become reactive to the epithelial cells within the thymus, that means they reacted to the self-antigen and would attack our own tissues. That's bad. And we eliminate those T cells with negative selection. So self-reactive T cells are going to be destroyed. So we have a two-step process here. We are first going to rely on positive selection, so they need to have surface receptors. If they have surface receptors, they move from the cortex of the thymus to the medulla of the thymus. And then within the medulla, if they respond to self-antigens, they are destroyed via negative selection. And we have maturated T cells ready for action that can go back to the bloodstream. Let's talk B lymphocytes, or B cells. B lymphocytes develop in the red bone marrow initially. They're called B lymphocytes because they are initially isolated from the bursa of a chicken. We find, though, that within our bodies, though, they come from the red bone marrow. Now, as we look at B lymphocytes, they come from some fetal stem cells, some multipotent stem cells that are going to remain in our bone marrow and ultimately differentiate into those B cells. B cells that are self-activated or react to self-antigens, we need to eliminate. So we deactivate or kill those so we won't have an immune response, an inappropriate immune-based disease. And self-tolerant B cells, so B cells that do not attack self-antigens, are going to synthesize surface receptors that bind to a specific antigen. And then when activated, they divide very rapidly and make immunocompetent drones, or excuse me, clone cells. And then as they are cloned, they leave the bone marrow tissue and then go colonize lymphatic tissues and organs throughout the body, just like the T cells do. So they can travel to lymph nodes, and then when they're activated within the lymph node, they can become a plasma cell, and then as a plasma cell, they can travel to other tissue types of the body and aid with the adaptive immune response. Now, as we look at T cells aren't able to be activated all by themselves. They can't recognize antigens on their own. They need a helper, and that helper is referred to as an antigen-presenting cell, an APC. Classic examples of antigen-presenting cells include dendritic cells, macrophages, reticular cells within our lymph nodes, or certain B cell types. All of these antigen-presenting cells are going to have the correct major histocompatibility complexes, the correct MHCs on their surface. These MHCs are kind of like the backstage pass at a concert. They are the identification tag that allows for the cells of our bodies to recognize other cells that belong in our body. And from human to human, these MHCs are going to be structurally unique, except when we're working with genetically identical twins. So let's look at this flowchart for a classic antigen-presenting cell. This antigen-presenting cell will phagocytize an antigen. That antigen is going to be wrapped up in a phagosome that fuses with a lysosome to make a phagolysosome. That phagolysosome will have digestive enzymes in it that take the antigen and chop it up into little pieces. Most of those little pieces are going to be exocytized. They are just going to be ejected out. But a couple of those little pieces are going to be scooped up and then put on the surface of our antigen-presenting cell. And those little pieces that are put on the surface are called epitopes. And they're held in place by an MHC protein. It's kind of like when my little kids find a bug, and they're so excited about their little buggy friends. And my kids are 3, 4, 5 years old. So when they find little buggy friends, they accidentally kill the bugs all the time because they play with them too aggressively. And then they'll be like, "Hey, Dad, look what I found." And they'll show me a bug's leg and be like, "Oh, isn't it cool?" My kids are kind of like antigen-presenting cells. They capture something, break it into little pieces, and then show somebody else the little pieces of what they broke apart. That's what these antigen-presenting cells do. They capture an antigen, break it into little pieces, and then show other cells of the adaptive immune system the little pieces of what they chopped up. So as we look at this antigen-presenting process, we'll have T cells roaming through the body, inspecting antigen-presenting cells for any antigens that may be on display. If an antigen-presenting cell only displays self-antigens, the T cell is like, whatever, this is boring. You belong here. You're clearly a cell that belongs here, but you don't have anything cool to show me, so I'm going to move on to the next cell type. If an antigen-presenting cell displays a non-self antigen, that T cell is then going to initiate the immune response, the adaptive immune response. And this antigen-presenting cell is capable of alerting our immune system to foreign antigens that just don't belong there at all. Now, the key to a successful immune response or a successful defense is that we need a very quick, and I can't emphasize this enough, we need a quick response. We need to quickly mobilize our cells or our adaptive immune system against the antigen. And since there are so many different kinds of cell types involved with immunity, we need to have extra special chemical messengers for coordinating this. And this is where the interleukins come in, this category of cytokine, interleukin. We'll talk about those more in subsequent recordings. If you have any questions or comments about B lymphocytes, T lymphocytes, or antigen-presenting cells, please feel free to post them in the class discussion board or to shoot me an email. Happy studies.